morning. It is May 29th, Friday, and today we can deal with percents and fractions by converting to a decimal and multiplying. I just want to clarify in this aim here, for percents, we're converting to a decimal. For fractions, we're just multiplying. This is a very, very, very important SAT lesson. They love asking questions about this. It's really 7th grade math. So you have seen this trickled into the Regents courses, but just because it's 7th grade math doesn't necessarily mean it's the simplest thing in the world, but at the same time, it's really not that complicated. So for percents or fractions, again, for a percent, we want to convert to a decimal, and then you're basically multiplying that by the whole to get the part. Convert percent to a decimal by dividing by 100. The percent of something not happening is 100 minus the percent it will happen. So what that means is if there's a, well, I think it says it here. If something has an 80% chance of happening, then there's a 20% chance of it not happening. The probability of something happening and the probability of something not happening must add to 100%. So if the probability of something happening is 70%, the probability of it not happening is 30%. If the probability of something happening is 26%, and the probability of it not happening is 74%. In all cases, the probability of something happening and the probability of it not happening has to always add to 100, so we're subtracting from 100 to find the probability of it not happening. All right, we did a lot of talking. Let's do some doing. Find 80% of 90. So I'm going to convert the percent to a decimal. We've done that a lot in this course already by dividing by 100 or moving the decimal 2 places to the left. Either way, it's 0.8. So if I want 80% of 90, I convert the 80% to 0.8, and I multiply by 90. Basically, of means multiplication, so if you ever see of, you're multiplying. You can use the calculator if you need to. 72 is your answer. There's a lot of, by the way, there's a lot of little pieces to this lesson. There's a lot of different types of questions they ask you. So it's a little bit of a long lesson. As you can see, there's a lot of pages here. Why don't you try number 2 on your own? I'll give you about 30 seconds. For percents, convert the percent to a decimal by dividing by 100 or moving it 2 places to the left. I'd say at this point for SAT, you're going to want to be able to do it by moving it 2 places to the left. Multiply by the whole. Use your calculator if you need to. 0.38 times 120 is 45.6. Number 3, it's a fraction now. Same thing. Of means multiplication. So if I want to do 3/4 of 98, I'm just multiplying 3/4 and 98. You don't have to worry about converting to a decimal when you're dealing with fractions. Just multiply. 3/4 times 98 is, my calculator told me 147 over 2, which is 73.5. I'm going to skip number 4. I think you can do that on your own. Let's take a look at 5. 60% of what number is 30? So again, I'm going to convert my percent to a decimal by dividing by 100. Now, it's 60% of what number? So it's 0.6 times x equals 30. I'm not asking for 60% of 30. I'm asking for 60% of what number? So it's 0.6 times x equals 30. From there, to solve for x, I divide by 0.6. 30 divided by 0.6 is 50. A 124% of what number is 62? So you can have percents over 100 depending on the situation. That would become 1.24. So it's 1.24 times what number is 62? I'm going to give you a few seconds to try and set this up on your own from here. I'll give you about 20 seconds. So it's 124% of what number? So 1.24 times x equals 62. From here to solve it, 62 divided by 1.24 is 50. 5/6 of what number is 80? Well, why don't you try this on your own? Use the ones we just did as a model. And why don't you try this on your own? I'll give you about 45 seconds. Five sixths times x equals 80. Now to solve this, some of you are afraid of fractions. Hopefully you're not. If you're an algebra 2 student, I can just multiply by the LCD to get rid of the fraction. 480 over 598, I think. 96. Now, what you could have also done, you could have just divided by 5/6 and put that into your calculator. But again, if it's a non-calculator question, you have to know how to deal with fractions. You just multiply by the LCD. But yes, you could have divided both sides by 5/6. That will give you the answer. So we're going to skip ahead to number 9. This is just kind of a word problem version of what we just did. David conducted a study and found that 32% of students like to sing. If a class has 250 students, how many would expected to like to sing? So 32% of the students like to sing. There's 250 students. So I'm finding 32% of 250. I want you to try and finish this question from here. I'll give you about 30 seconds. .32 times 250. Use the calculator. 80. So if it's a word problem with the percent, it's the same exact thing. So don't be afraid of it. Same type of thing here. So it's we'll go through it. A building has dimensions 30 feet long, 40 feet wide, 80 feet tall. A model is to be made of this building where all the dimensions are 1/16 of the original. How tall will it be? So I want 1/16 of how tall it's going to be, which is 80. I want 1/16 of 80. The other information is just kind of unnecessary. You have to kind of just understand that we don't need that since it's asking for how tall the building will be. I want you to try and finish this problem from here. I'll give you about 20 seconds. One 1/16 times 80 is 5. All right, now here's where we're going to add a new twist. 45% of a baker's revenue goes to cost, and the rest is profit. How much profit does the speaker make if his revenue is 250? So it says that 45% is cost. The question's asking about profit. It says the rest is his profit. So if 45% is cost, then 100 minus 45, 55% is profit. That's what we talked about at the beginning. The probability of something not happening, you would have to subtract from 100. The probability of something happening and the probability of something not happening has to add to 100. So if 45% is cost and it says the rest is profit, then 55% is profit. So 55% of his revenue is going to be profit. From here, 0.55 times 250 is 137.5, and we're talking about money, so it's 137.50. So again, a big twist. If it wants the probability of something not happening, you have to subtract that probability from 100 and go from there. 80% of the students in a class study for their math test. There are 32 students in the class. How many did not study? Well, if 80% studied, then I want you to tell me what percent didn't study. I'm going to give you about 8 seconds. 80% studied, what percent didn't study? Time's up. 20% did not study. So you have to be real careful when you're reading. So 20% of 32 students didn't study. So 0.2 times 32 is 6.4. So I would say approximately 6. So again, if it wants a probability of something not happening, you have to subtract that probability from 100. Now, with fractions, so 3/5 did their homework, it says how many students did not do their homework. It's the same concept. The 3/5 did homework. So to determine the fraction of students who didn't, you're not subtracting from 100, but you're subtracting from 1. Or think of it this way. If 3 out of 5 didn't, if 3 out of 5 did do it, then 2 out of 5 did not do the homework. So yes, you're essentially still subtracting from 1, or you can just think of it as the numerators have to add to a whole. And if you're doing this by mathematically, 1 is 5 over 5, and you would end up with 2 over 5. But it might be easier to think of it as, well, if 3 out of 5 did it, then 2 out of 5 did it. Either way, they're adding to 1. So 2/5 of 20 did not do their homework. So 2/5 times 20 is, again, if it says not, you have to subtract from 100 if it's a percent, or from 1 if it's a fraction or a decimal. All right, this is another different type of question dealing with percents. I've seen this in the SAT a couple times. David is buying ham and turkey from a deli. The ham contains 6% fat and the turkey contains 2% fat. If his purchase contains 8 grams of fat, write an equation that models this relationship, where X is the number of grams of ham and Y is the number of grams of turkey. Well, let's start with the ham. So X is ham, grams of ham. And Y is grams of turkey. So how much fat is in the ham? Because the total purchase is total grams of fat. So we want an equation to represent the total number of grams of fat. So if 6% is fat, then 0.06 times the number of grams of ham is going to give you fat. 0.06x represents the number of grams of fat from ham. Since 6% of the ham is fat, 0.06 times the number of grams of ham is fat. Well, that's how much fat we're getting from the ham. How much fat are we getting from the turkey? Well, if it's 2% fat, then I'm multiplying the number of grams of turkey by 0.02. So this is the amount of fat from the ham. This is the amount of fat from the turkey. So together, it's going to add to the total fat, which is 8. I would not consider this super simple conceptually, but listen, this is SAT prep, essentially. This is something that you need to be able to do. Again, this equation represents the total amount of fat, the amount of fat you're getting from the ham. It's 6% of the total amount of ham, so 0.06 is 6%, and x is the total amount of ham. The amount you're getting from the turkey, it's 2% fat, so I'm multiplying the total number of grams of the turkey by 0.02, and the amount of fat from the ham plus the amount of fat from the turkey is going to equal the total amount of fat for the purchase, and it says the purchase contains 8 total grams of fat. Now, it's not asking me to solve this equation. In fact, I can't solve it because it has 2 variables. It just asks me to set it up. And when this has come up on the SAT, it comes up as a multiple choice question. So this is your answer. 15 is pretty much the same thing as 14. I want you to try it right now on your own. It is a little tricky, so I'm going to give you about a minute and a half in order to do it. Okay. In a certain high school, 25% of the freshmen and 30% of the sophomores have blonde hair. There's a total of 120 freshmen and sophomores with blonde hair. Write an equation that models this relationship where x is the number of freshmen. So x is freshmen, y is the sophomores. So this is how many people have blonde hair. So how many freshmen have blonde hair? Well, 25% of the freshmen have blonde hair. So the amount of freshmen that have blonde hair is 25% times the number of freshmen. Look at it this way. 25% of freshmen. That's represented by this. 30% of the sophomores. So this is the amount of freshmen that have blonde hair. The amount of sophomores that have blonde hair is 30% of the sophomores. A little scrunch there. That's represented by that. So this is the blonde freshmen. This is the blonde sophomores, and it says there's a total of 102 blonde freshmen and sophomores. That's your equation. Hopefully it makes sense. It's not the easiest thing in the world, but hopefully at this point it makes sense. If you're increasing or decreasing by a percent, It's 1 plus or minus the decimal. Plus for increasing, minus for decreasing. We did this a lot in Algebra 2. So this really shouldn't be foreign to you. There's a couple of examples. If I'm increasing by 12%, I am doing 1 plus 0.12 for 1.12. If I'm decreasing by 20%, I'm doing 1 minus 0.2, which is 0.8. Other than that, it's the same thing we did at the beginning of this lesson. But if you're increasing or decreasing by a percent, you're adding or subtracting that amount to 1. Byron purchases groceries that total $52. How much will his bill be after 7% sales tax? So if it's 7% sales tax, it means that we're increasing the amount you're paying by 7%. So it's 1 plus, and if I convert that to a decimal, I get 0.07, not 0.7. 1 plus 0.07, which is 1.07. Again, if you're paying tax, you're increasing the amount that you're paying. So it becomes 1.07 times 52. Same thing beginning of the lesson. Whenever I have a percent, I'm multiplying. In this case, I have to add that percent to 1 since that's the amount it's increasing by. And when I type that into the calculator, I get $55.64. If I'm increasing or decreasing by a percent, I have to add or subtract the decimal to 1. A $500 television goes on sale for 20% off. How much will the cost of the television be without tax? Well, if it's 20% off, then you're paying 80%. So I'm paying 80% of 500. So it's 0.8 times 500, which is 400. If it's 20% off, then I'm paying 80%. I'm either think of it as subtracting 20 from 100, or you can think of it as subtracting 0.2 from 1, either way, and you'll get your answer. Again, once you have your percent, you're just multiplying, which is what we've been doing all along. The population of a county increases by 1/3. So if it's increasing by 1/3, then I'm adding 1 plus 1/3. If you're not good with fractions, you can use the calculator. If it's not the calculator section, increasing 1 plus 1/3 is 4/3. So if it's increasing by 1/3 and the initial population was 4,500, then it's 4/3 times 4,500. Again, if it's increasing or decreasing by a percent or a decimal, we treat them the same exact way. You're adding or subtracting it to 1. And again, if it's a percent, you want to think of it as adding the percent to 100. That's the same thing. So I'm doing 4/3 times 4,500, and I got 6,000. So again, if I'm increasing or decreasing by a percent or a fraction, I'm adding or subtracting that to 1. Once I have that value, I'm just multiplying by the total number. This one looks like it got cut off. Either way, you can try that one on your own. Same type of thing there. Actually, wait. So 21 is going to change a little bit. So it says that Jamie paid $32.40 for a sweater after 8% sales tax. What is the cost of the sweater before the tax? So after, if it's, again, tax is increasing. So if it increased by 8%, we're talking 1.08. Now, we're not increasing this amount by 8%. This is the amount after. So 1.08 times the original cost is going to equal the cost after tax. So If I multiply the original cost by 1.08, that will give me my final cost. In this case, it gave me my final cost. It said that she paid $32.40 for the sweater. This is after the tax. So because, and this is something we did earlier in the lesson as well, because because it's asking for the original, then the 1.08 goes with the x. And then from there, I'm dividing by 1.08. And that will give me my answer, which is 30. So be careful if they're giving you the before amount or the after amount. You're always multiplying the original, the before, by the percent or the fraction or whatever to end up with your final cost. If they give you your final cost, then you're going to have to put an X after the percent or the decimal or the fraction. Why don't you try number 22 on your own? Again, as a hint, she paid $22.50 after the sale. So that's what she actually paid. That was the amount after the 25% off, and it's asking for the original. So this one's going to be similar to number 21. Try it on your own. Okay, so it's a 25% off sale. So that means that you're paying 75%. So 75% of what is $22.50? That's how we set it up. All right, if it's 25% off, then you're paying 75%. So 75% of what original price is $22.50. That's the setup. From here to solve it, we divide both sides by 0.75. $22.50 divided by 0.75 is 30. So again, if you're increasing or decreasing by a percent, you're adding or subtracting that amount to 1 or a fraction. By increasing or decreasing by a percent or a fraction, you're adding or subtracting that amount to 1. And be careful, the value that they give you, it might be the original or it might be the after amount. If it's the original, then you're just multiplying them. If it's the after amount, then you're multiplying by x to equal the after amount. Basically, I said at the very beginning in the notes, it's the decimal times the whole equals the part. It's the decimal times the original equals the after amount. It's another way of thinking of it. All right, what do we got left? After increase, same type of thing, same type of thing, same type of thing. All right, and there's one more thing to talk about, and I know this is a long lesson because it's really a lot of lessons. It's really a whole unit. It's really a whole percents and fractions unit, but we're kind of just doing it all at once here. Compound percents and fractions. If you are applying multiple percents or fractions, you're multiplying them by each other. Basically, if we're doing more than one percentage or fraction, we're just multiplying them all instead of just multiplying the two. Right? We're multiplying for all these, so now we're just going to do additional multiplications. A jacket has an original price of $80. It is on sale for 30% off, and Jackson has a 20% off coupon. Without sales tax, how much will Jackson have to pay for the jacket? This is what I do all the time when I go shopping. I go to the outlets, they have their percentages off, I have my coupons. This is literally what I do, and I'm literally doing the math in my head when I go to these stores. So again, it's not about what you're not paying, it's about what you are paying. So if it's on sale for 30% off, what percentage are you paying? Well, you're paying 70%. Then Jackson's a 20% off coupon. So if it's 20% off, then you're paying 80%. Now the way it works, you don't add up the percentages. If it's 30% off and another 20% off, it's not 50% off. It's 20% off of the new value, not off of the original value. So they're going to take 30% off. You're going to end up with a new value, and then 20% off comes off of that new value. It's not the same as taking 20% off of the original. So I have two percentages. I'm paying 70% of 80% of $80. So if you have multiple percents, you're just multiplying them all together. And again, same thing. If it's not about what you're not paying, it's about what you are paying. So if it's 30% off, if it's decreasing by 30%, you're subtracting that from 30. Same thing if it's decreasing by 20%, you're subtracting that from 100 as well. So from here, you put that into your calculator. 0.7 times 0.8 times 80 is 4040. Again, if you have multiple percents or fractions, you're just multiplying them all together. Chloe wants to buy a car that has an original price of $8,000. The dealership is offering 10% off, and her mom will pay 1/4 of the final cost. How much will Chloe have to pay without tax? Well, 10% off. 10% off is 1 minus 0.10, which is 0.90. Her mom is paying 1/4 of the final cost. So what's Chloe paying? 1 minus, a little too sloppy. She's paying 1 minus, oops, 1/4, which is 3/4. So she's paying 90% of 3/4 of 8,000. Again, if you have multiple percents or fractions, you're just multiplying them all together. She's paying 90% of 3/4 of 8,000. Think of it as what she's paying. All right, when you're taking things off, as long as you think of it as what she's actually paying, that should make it more clear. If it's 10% off, she's paying 90%. If her mom is paying for 1/4, she's paying 3/4. So she's paying 90% of 3/4 of 8,000. You multiply them all together. 0.9 times 3/4 times 8,000. $5,400. A lot better than paying 8,000, I'll tell you that. We just got two more. Why don't you try number 28 on your own right now? And after that, we'll go over that, and the rest you'll practice. Try number 28 on your own. I'll give you about a minute and a half. Okay. Increased by 8%. That's 1 plus 0.08, which is 1.08. Increased by 11%. 1 plus 0.11, which is 0.11. So there's an 8% increase of an 11% increase of 52,000. That will give you the amount the following year. It increased 8%, then it increased 11 more percent, so it's 1.08 times 1.11 times the original. And I got 62337.6. So we'll say that's approximately, because we can't have a sixth of a person, 623. And that's it. So if you have a compound percent, then you are just, doing the same thing you've been doing, converting them to a decimal or a fraction. If it's increasing or decreasing, you're adding or subtracting it to 1, and you're just multiplying both of those by the original instead of just 1. So, a lot we talked about here. I wasn't looking forward to recording this lesson because I know it's so long, but got through it. When you're dealing with percents, convert it into a decimal by dividing by 100, and then you're multiplying the decimal or the fraction by the original or the whole to get the part or the after amount. The percent of something not happening is 100 or 1 minus the probability it will happen. We started off pretty basic. Again, just convert it to a decimal and multiply. If you're looking for the original, then you might be x. If it says 60% of what number, well, then it's 0.6 times x. That's what it's trying to find. And we have to do the algebra from there. Word problems don't change that. You just have to just kind of understand what's going on. The probability of something not happening is 100 minus the probability that it will happen. So here, when it said that it's all cost and profit, if it says that it's 45% cost, we subtract from 100 to find the profit. Same thing here. If 80% studied, then 20% didn't study. 100 minus 80 is 20. When you're increasing or decreasing by a percent, again, we did that a lot this year in Algebra 2. We're adding or subtracting that percent to 1. Adding if it's increasing, subtracting if it's decreasing. So when I added 7% sales tax, that means it's increasing by 7%. So I came up with 1.07. If it's decreasing by 20%, then it's 1 minus 0.2, it's 0.8. And finally, compound percents or fractions. If you have 2 or more percents or fractions being applied, you're just converting them both to decimals or leaving them as fractions and multiplying them all together. So I'm giving you a couple extra days to do this. Today's Friday. This isn't going to be due until like Wednesday, so you have plenty of time. You're not going to have a new lesson on Monday. Your classwork/homework is to finish all the percents. It's a long quiz. It's 5 questions. I'm making it due on Wednesday. And it's long because there's a lot of different types of questions. This is like a whole unit from 7th grade. There's actually another lesson that I didn't put in here. It's in this is a condensed packet. My actual SAT packet is a lot longer than this, but there's no way we're getting through all of that. So there's also a percent of change lesson, but I didn't incorporate it into this. It's a little bit different. But there's a lot they ask about a percent in the SAT, so we want to make sure we're prepared for it. Any questions, reach out to me and remind, and have a great day.